Hello. In this video, I'm going to teach you about the uses and properties of electromagnetic waves. As a reminder, electromagnetic waves happen when an electric field and a magnetic field change. And when they change, they cause each other to change. So the electric field changes the magnetic field and vice versa. This happens in a pattern, so you end up with something that looks very much like a transverse wave. And we call it light. First, let's talk about the divisions of this spectrum. So, light is a wave. It can have literally any wavelength, or any frequency. But it's not easy for human beings to talk about spread out things like this. Humans like to have little chunks, mental pieces that we can hang on to. And so what scientists have done is they've broken it down into several sections and given every section a name. These sections are kind of arbitrary. That means we could have made them anywhere, but we made them in specific places just because we had to draw them somewhere. We have radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, and gamma. On the radio wave side, they are very large. They have a big wavelength. They also have a low frequency, and they have low energy. On the right, we have gamma rays, which are very small, but they have a high frequency, and they have a lot of energy. I'm going to normally be referring to these in terms of energy, but you should know that low energy waves are always going to be large wavelength and low frequency. And high energy waves are always going to have a small wavelength, so they're going to be small, and high frequency, so they're going to be moving up and down very quickly. So before I start, I want to talk briefly about vocabulary. In the regular non-scientific world, people like to say radio and microwaves. They like to say infrared, visible, and ultraviolet light. They like to say X and gamma radiation. But to a physicist, these are all made of the same thing. They're all made of those oscillating electric and magnetic fields. And so because they're all made of the same thing, these words are all the same. Light, radiation, and electromagnetic waves. These are all synonyms. And so I might use any one of them to talk about light. Let's start talking about radio waves. Radio waves have very large wavelengths and low energies. So this makes them perfect for the long-distance transmission of information. There are two major reasons why this is true. First, they're big enough to wrap around buildings and mountains. They're not going to bounce off of a building or a mountain. They're going to wrap around it. And so you're going to be able to get to houses and receivers on the other side of obstacles, which is what you want. And second, they're low energy, so you can make them work without using lots and lots and lots of power. So you can use small batteries instead of a gigantic supercharger station. Radio waves are used in radio stations, TV stations, GPS, that's how your phone knows where it is, and MRIs. That's a medical diagnostic system. It's used in a lot of other places too. Microwaves are next up on the list, next highest energy. They are big and they have low energies, a lot like radio waves. They're sometimes used for communication also. So for example, cell phones will use microwaves to transmit information. They use microwaves and not radio waves, first of all because radio already uses radio waves, but second of all because microwaves can be made with a less big antenna. So the giant radio stations, those are huge. You can't carry that around in your pocket. Cell phones are smaller, so they can make smaller waves, microwaves. To detect medium-sized objects like cars or airplanes, radar sensors use microwaves also. So microwaves are used in radar sensors too. Microwaves don't have very much energy, but they happen to be just the right size to interact with water molecules and make them jiggle around. As a result, microwave ovens can use microwaves to heat up food. They jiggle around water molecules, and then this jiggling rubs with other water molecules, and it gets hot because of friction. Now let's talk about infrared light. Infrared literally means below red. Infra means below, and red means red, obviously. So infrared is a set of wavelengths just a little bit less energetic than red light. It's invisible to humans, just barely, but some animals can see it. Infrared light is released by human beings and warm-blooded animals as they maintain a high body temperature. As a result, infrared radiation is used in night vision and heat sensors. If you've ever seen something like this, maybe you saw the movie The Predator, or you've just seen a night vision camera or a heat vision camera, it works because it picks up infrared light. So these are all infrared pictures. It's also used in heaters, because infrared radiation can warm up your body. Now let's talk about visible light. Visible light is a set of frequencies that you can see with your own eyes, all the colors you can see. Every other frequency is invisible to humans. It's all the colors that a human being can see, and therefore all the colors of the rainbow belong in this part of the electromagnetic spectrum, of this box. Visible light, this box that I drew, actually contains red, orange, yellow, green, blue, indigo, and violet inside of it. They're all different sub-parts of this box, so it's cut up into sections. Red has a big wavelength, a low frequency, and a low energy. Violet has a small wavelength, a high frequency, and a high energy, because of where they are in the spectrum. Left is always going to be big and low energy. Right is always going to be small and high energy. So I'm not going to tell you the uses of visible light because you already know how useful it is to be able to see things. Visible light is what lets you view the world. Now let's talk about ultraviolet light. Ultraviolet literally means above violet. Ultra means above, and violet means violet. So ultraviolet light is energetic enough to cause significant changes to many molecules, and as a result, it disrupts many organic molecules that you need to live. It's used to kill bacteria, so like sterilizing medical equipment, and it can cause cancer in humans if they stay out in the sun for too long. That's why you had to wear sunscreen, to avoid skin damage. It's not all bad though. The human body also uses ultraviolet light to synthesize vitamin D in skin cells, so it's not just harmful. Now let's talk about X-rays. X-rays are very energetic and therefore they can be really dangerous. They can pass through muscle and skin, which allows them to be used for medical imaging. This is where you've probably heard of X-rays when you go to the doctor's office or the dentist's office and they take a picture of your skeleton to see if everything's okay. They're also used at airports to look inside of luggage. Those machines that you put your suitcase in and it rolls through and they look for weapons or unauthorized materials, those use X-rays to look through them. Finally, let's talk about gamma rays. Gamma rays have very, very small wavelengths and very, very high energies. They're created by intense astronomical events like quasars or supernovas. Some of the most violent things that nature can create are gamma rays. They're also used in medical applications. So for example, radiation therapy for cancer, they use gamma rays to do that, to sort of kill tumors and cancer inside cells. When it comes to safety, the lower end of the radiation scale is normally pretty safe for humans to interact with. But the more energetic radiation is usually associated with a risk of developing cancer and it should be avoided if possible. So ultraviolet, X-rays, gamma rays, not very good for you. Finally, to summarize, light, radiation, and electromagnetic waves are all different names for the same thing. Every part of the electromagnetic spectrum has its own uses. Radio waves are used for radio stations, TV stations, GPS, and MRIs. Microwaves are used in cell phones, radar sensors, and microwave ovens. Infrared light is used in night vision, heat sensors, and heaters. Visible light is everything you can see. All the colors are visible. They all belong in this box. Ultraviolet light is used to kill bacteria, synthesize vitamin D, and can cause cancer. X-rays are mostly used for medical imaging. Gamma rays are used in radiation therapy for cancer. And that's it.